Have you ever looked at a pizza and seen a circle? It's not just a delicious meal, but also a perfect example of geometry in everyday life. Think about it. Every slice you take is a part of that circle, and each bite brings you closer to understanding the beauty of shapes. Or maybe you looked at a clock and saw one too? Circles are everywhere. From the face of a clock that helps us keep track of time, to the wheels on a car that take us places. These circles are not just shapes, they are essential parts of our daily lives. And guess what? Circles love to hang out with angles. When you start exploring geometry, you'll find that angles and circles are best friends. They work together to create fascinating patterns and solve intriguing problems. Imagine drawing a circle and then measuring the angles inside it. It's like uncovering a secret code. Today, we're going to learn a cool trick about circles and angles. This trick will not only make you better at geometry, but also help you see the world in a new way. You'll start noticing circles and angles in places you never thought to look before. It's like having a superpower. It's called the Inscribed angle theorem. Sounds fancy, right? But don't let the name scare you. This theorem is actually quite simple once you get the hang of it. It tells us something amazing about the relationship between angles and circles. Imagine being able to predict the size of an angle just by looking at a circle. That's the magic of the Inscribed angle theorem. Don't worry, it's actually super fun. Learning about the Inscribed angle theorem is like solving a fun puzzle. You'll get to use cool tools like protractors and compasses, and you'll feel like a detective uncovering hidden truths. Plus, you'll get to impress your friends with your new knowledge. So, let's dive in and start exploring the wonderful world of circles and angles together. Imagine drawing a smiley face inside a circle. The curved part of the smile, where it touches the circle, that's kind of like an inscribed angle. It's an angle made by two lines called chords. These chords meet on the circle, creating a little angle inside. Now, here's the magical part. The Inscribed angle theorem tells us that this angle we made, our inscribed angle, is half the size of the arc it's eating. What's an arc? Imagine the pizza again. The crust of one slice is an arc. So our angle is like a hungry little guy, and the arc is its yummy pizza crust. Let's say we have an inscribed angle in a circle. That's eating an arc of 100 degrees, a significant portion. How big is our angle then? Remember, the angle is always half the size of the arc it intercepts. So the angle would be 50 degrees. See? Easy peasy, right? Section 5. Example 2. When a diameter plays a role. In this section, we will explore the fascinating role that a diameter can play in the geometry of circles. Understanding this concept is crucial for solving many problems related to circles. What if one of our chords is a diameter? A chord, as you may recall, is a line segment with both endpoints on the circle. But when this chord passes through the center of the circle, it becomes a very special chord known as the diameter. A diameter is a line that goes through the center of the circle, like cutting a pizza straight down the middle. Imagine slicing a pizza perfectly in half. The cut goes through the center, dividing the pizza into two equal parts. This is exactly what a diameter does to a circle. If a diameter is part of our inscribed angle, it gets even cooler. An inscribed angle is formed when two chords of a circle meet at a point on the circle. When one of these chords is a diameter, the properties of the inscribed angle become even more interesting. The arc it eats is always 180 degrees, half the circle. This is because the diameter divides the circle into two equal halves, each representing an arc of 180 degrees. This property is fundamental in understanding the relationship between diameters and inscribed angles. So, our inscribed angle would be half of 180 degrees, which is 90 degrees. This is a direct consequence of the inscribed angle theorem, which states that an inscribed angle is half the measure of the intercepted arc. That means it's a right angle. A right angle is an angle of exactly 90 degrees, and in this case, it is formed by the inscribed angle that intercepts the 180-degree arc created by the diameter. This concept is not only fascinating, but also very useful in various geometric applications. Understanding this relationship helps in solving many geometric problems. For instance, if you know that a diameter is involved, you can immediately conclude that the inscribed angle is a right angle. This can simplify your calculations and make problem solving much more efficient. The concept of diameters and right angles is not just limited to theoretical problems. It has practical applications in real life as well. For example, engineers and architects often use these principles when designing structures like bridges and buildings. The stability and symmetry provided by right angles and diameters are crucial in these fields. In the classroom, understanding the role of diameters can help students tackle a variety of geometry problems with greater ease. Teachers often emphasize this concept to build a strong foundation in circle geometry, which is essential for more advanced mathematical studies. As you practice more problems involving circles, you'll find that recognizing when a diameter is involved can be a powerful tool. It allows you to quickly identify right angles and make accurate calculations, enhancing your overall problem-solving skills. So, the next time you encounter a circle problem, remember to look for the diameter. Its presence can simplify your work and lead you to the right solution more efficiently. The diameter is not just a line through the center. It's a key player in the world of circle geometry. That wraps up our exploration of diameters and their role in circle geometry. Keep practicing, and you'll soon master this important concept. Remember, geometry is all about understanding the relationships between different shapes and their properties. Happy learning? Section 6, Example 3, Inscribed Angles and Triangles. In this section, we will explore the fascinating relationship between inscribed angles and triangles within circles. This is a fundamental concept in geometry that helps us understand the properties and behaviors of shapes. Inscribed angles can even be part of triangles inside circles. When we talk about inscribed angles, we are referring to angles whose vertex is on the circumference of the circle and whose sides are chords of the circle. These angles have unique properties that make them very interesting to study. Let's say we have a triangle inside a circle, and one of its angles is an inscribed angle. This means that the vertex of this angle lies on the circle, and the sides of the angle are chords of the circle. This setup creates a special relationship between the inscribed angle and the arc it intercepts. If we know the measures of the other two angles in the triangle, we can use what we know about triangles to find the measure of our inscribed angle. Triangles have a total internal angle sum of 180 degrees. By knowing two angles, we can easily calculate the third angle. Remember, all the angles inside a triangle always add up to 180 degrees. This is a fundamental property of triangles that is always true, regardless of the type of triangle. Whether it is an equilateral, isosceles, or scalene triangle, the sum of the interior angles will always be 180 degrees. Now, let's delve deeper into the inscribed angle theorem. This theorem states that an inscribed angle is always half the measure of the intercepted arc. For example, if the arc intercepted by the inscribed angle measures 100 degrees, the inscribed angle itself will measure 50 degrees. This property is incredibly useful when solving geometry problems involving circles and triangles. By understanding the relationship between inscribed angles and their intercepted arcs, we can solve for unknown angles and gain deeper insights into the geometry of circles. Let's consider a practical example. Suppose we have a circle with a triangle inscribed in it. We know the measures of two of the angles in the triangle. Using the inscribed angle theorem, we can find the measure of the third angle by first determining the measure of the intercepted arc. First, we calculate the measure of the intercepted arc by doubling the measure of the inscribed angle. Then, we use the fact that the sum of the angles in a triangle is 180 degrees to find the measure of the unknown angle. This step-by-step approach makes it easier to solve complex geometry problems. To summarize, inscribed angles and triangles within circles are interconnected through the inscribed angle theorem. By understanding this relationship, we can solve for unknown angles and gain a deeper appreciation for the beauty of geometry. Keep practicing these concepts, and you'll become proficient in solving geometry problems involving inscribed angles and triangles. Remember, practice is key to mastering geometry. Work on different problems, discuss with your peers, and seek help from your teacher whenever needed. The more you practice, the more confident you'll become in your ability to solve geometry problems involving inscribed angles and triangles. Keep exploring the world of geometry, and you'll discover many more fascinating concepts and relationships. Happy learning! Section 7. Practice time. You got this. Ready to try some problems on your own? I bet you are. Remember, the inscribed angle theorem is like a fun little puzzle. Just think of the angle as eating its arc, and you'll be a geometry master in no time. Section 8. Why is the inscribed angle theorem important? You might be wondering, why do I need to know this? Well, the inscribed angle theorem is super helpful for all sorts of things. Engineers use it to design bridges and buildings. Architects use it to make cool shapes and designs. Even artists use it to create beautiful paintings and sculptures. Section 9. Connecting the dots. Other geometry wonders. The inscribed angle theorem is also connected to other amazing things in geometry, like cyclic quadrilaterals and tangents. These are like the cool cousins of inscribed angles, and they all love to hang out in the world of circles and lines. Section 10. Keep exploring the world of geometry. So, there you have it. The inscribed angle theorem is a simple yet powerful tool that helps us understand the relationship between circles and angles. Keep exploring, keep asking questions, and keep having fun with math.